Welcome to this video on flow control in computer networks. In this video, we will understand how flow control ensures efficient and reliable data transmission between sender and receiver. Flow control mechanisms prevent the sender from overloading the receiver with too much data at once. We will explore important techniques such as stop and wait, sliding window, and rate-based flow control and see how they help maintain smooth communication across the network. By end of this video, you will clearly understand why flow control is essential for maintaining data integrity and network performance. The importance of flow control in data communication is wide-ranging and essential. First, it prevents data loss by ensuring that the receiver's buffer does not overflow, keeping every bit of data safe. Next, it maximizes throughput, allowing the network to use its resources efficiently without overloading any part of the system. Flow control also maintains system stability, especially in hardware data paths, by preventing internal models from stalling or crashing due to excessive data input. And finally, it enhances fairness, making sure that all data streams or connections share the network resources evenly, particularly in environments like switches or routers. In short, flow control keeps the data communication process smooth, efficient, and reliable. The second aspect of data link control is flow control. Flow control refers to a set of procedures that determine how much data the sender can transmit before waiting for an acknowledgement from the receiver. The receiver uses a set of memory blocks known as the buffer to temporarily store the incoming data before processing it. If this buffer starts to fill up, the receiver must signal the sender to slow down or pause transmission until enough space becomes available again. To manage this process efficiently, two main techniques are used: stop and wait sliding window. These techniques ensure that data is transmitted smoothly and reliably without overloading the receiver. In stop and wait flow control, the sender transmits one data frame at a time and then waits acknowledgement from the receiver before sending the next frame. Only after receiving the acknowledgement does the sender proceed with the next transmission. This process of sending and waiting continues until an end of transmission frame is sent. The main advantage of this method is its simplicity. Every frame is verified and acknowledged before moving on, ensuring reliable communication. However, the disadvantage is that it is very slow. Each frame must travel all the way to the receiver and the acknowledgement must return before the next frame can be sent, which leads to a lot of waiting time. In sliding window flow control, the sender can transmit multiple data frames before waiting for an acknowledgement. This means that frames can be sent one after another, allowing the communication link to carry several frames at once, making much better use of the link's capacity. The receiver does not need to acknowledge every single frame. Instead, it sends a simple acknowledgement to confirm the receiving of multiple data frames at once. You can imagine sliding window at both the sender and receiver sides. These windows act like a imaginary boxes that hold a specific number of data frames. The size of the window determines the maximum number of frames that can be transmitted before an acknowledgement must be received. In the sliding window method, the sender can continue transmitting frames as long as the window is not full. Each frame is numbered sequentially from 0 to n minus 1. For example, if n is equal to 8, the frames are numbered 0, 1, 2, 3, 4, 5, 6 and 7, and then the numbering repeats 0, 1, 2 and so on. The window size is always n minus 1, meaning the window covers up to n minus 1 data frames at a time, not all n frames. When the receiver sends an acknowledgement, it includes the number of the next frame it expects to receive. For example, if the sender receives an acknowledgement with the number 5, it means that all frames up to 4, that is, frames 0 through 4, have been successfully received.